Welcome back to Discovering Geometry with Becky Berry. This is lesson 5, all about polygons. So we're going to talk about what a polygon is, how to classify them, how to name them, and the different types of polygons that we can have. Well, what is a polygon? Here's our picture. These three are different polygons, and these examples are not polygons. So what do we see about polygons? Well, they're closed figures, but these two are both closed. And what's the difference here? This one has a round side, this one has a round side. So we're looking at straight-sided closed figures. And just one close, not a crossing over in the middle. This one looks like two pieces. This one has some extra pieces. Our definition of a polygon is going to be a closed figure with straight lines. They're formed by connecting line segments endpoint to endpoint, and each segment intersects exactly two other segments. And again, those are at the endpoint. So if we're looking at this segment right here, we can say here's one endpoint and here's another, and it's going to intersect with this segment and this segment, so exactly two segments. We come to this one over here. If we look at this segment on the left, here's the two endpoints, and those endpoints connect to two different segments. What about how we classify polygons? Let's take a look at some pictures. Are these all polygons? And if they are, how could we sort them? They all have straight sides, they're all closed figures, and their segments connect to exactly two other segments at the endpoint. So they are all polygons. What's the difference between all of these? Hopefully you remember this from just elementary math classes and studying shapes. We talk about the different number of sides they have. So our main way of classifying polygons is by the number of sides they have. So let's talk about all the different names. Hopefully a lot of them are familiar. A triangle has 3 sides. A quadrilateral is what we're going to use for 4-sided figures. Then we can get more specific about squares or rectangles or rhombuses or trapezoids. All of those are quadrilaterals. They have 4 sides. A pentagon has 5 sides. A hexagon is what we call a shape with 6 sides. If it has 7 sides, we call it a heptagon. So that might be a new word for you. Hexagon and heptagon. 8 sides, like a stop sign, is an octagon. 9 sides is a nonagon. A decagon has 10 sides. And then 11 sides is a hendecagon, or sometimes it is also called an undecagon. I think might be coming from the uni, which is 1, like a unicycle has 1, so it's 1 more than a decagon. But it's also sometimes called a hendecagon. We have a 12-sided figure we call a dodecagon. So again, adding that little prefix before the decagon, decagon meaning 10. So a dodecagon is 12. And then usually past that, there are some times you can find a name for a certain sided figure, but generally past 12, we just use an n-gon if it's n number of sides. So if it's a 25-sided figure, we would call it a 25-gon. So how do we name polygons? We've talked about naming points and planes and line segments. And so now we're going to name our polygons. We name polygons by listing their vertices in consecutive order. So we will label those vertices with letters generally capital letters because they're a point, right? An endpoint. And then we just go around in order, and it doesn't even matter which vertice we start with. It doesn't matter if we go clockwise or counterclockwise. Sometimes certain books like to go clockwise, but it really doesn't matter. But we don't want to go out of order. So we want to name them as we come to each vertice. So let's look at this. So our vertex, and then two vertex would be two vertices. So that's the difference between vertex is one and vertices is more than one. They are points or endpoints, so we give them this letter name. And then the line segments are the sides of the polygon. If I were to name this one, I could start at any letter. Let's just start at T, and I'm going to call it polygon T, P, Q, R, S. I could have started at R and gone the other direction. I could have said that this is polygon R, Q, P, T, S. So you can see the more vertices it has, the more names that you could use for it. Sometimes if it's just a triangle, we will put the triangle symbol before it. So we would say this is triangle ABC. You might use a quadrilateral symbol if it's before quadrilateral. Generally before one bigger than a quadrilateral, we're just going to list these and assume that we know. You might label it as a polygon, but if you have that many letters, it's probably a polygon. What about this one? What name would you like to give this one? Might make a lot of sense just to go in order on this one. We could call it polygon A, B, C, D, E. But remember, you could start anywhere, and so we could call it D, E, A, B, C. So practice naming your polygons. Remember that you just want to go in order around. So just connecting the dots, and you will have it named correctly. Okay, we're going to talk about drawing diagonals. But what is a diagonal? A diagonal of a polygon is a line segment that connects two non-consecutive vertices. So when we were naming them in consecutive order, but now we're going to draw a diagonal not to a consecutive vertice, but one across from it. So here's a picture of a pentagon. If I want to draw from A to another vertice, but not one that's next to it. So I'm not going to draw from A to B, that's not a diagonal. And I'm not going to draw from A to E, that's not a diagonal. But I could draw from A to C, and I can draw from A to D. So a pentagon has 5 sides. At any one point, you're going to not be able to draw to its own point, and you're not going to be able to draw to the 2 points next to it. So with 5 vertices, you're only going to be able to draw 2 different diagonals from that one point. However, we can draw diagonals from every vertice. So from B, I can draw to E or D. And from C, I can draw from A to E. Now, if I keep going around D, I can draw 2 diagonals, but they're already drawn. And E, I can draw 2 diagonals, but they're already drawn. So these are all the diagonals for this pentagon. And it makes a nice little star in between. What's the difference between convex polygons and concave polygons? So if I just look at the polygon, I see that all of these kind of push to the outside, and these all kind of come in. So that's really some definition of convex versus concave. Concave usually has a push in. If we want to actually define this, we would say all diagonals are inside the polygon for convex polygons. And for concave polygons, one or more diagonals are outside. So when I connect to the non-consecutive point here, so from this one to this one, I am not drawing that diagonal inside the polygon. You'll also see that cave part of the polygon. So all of these have a little cave on the side, at least in one place. And that might help you remember how to tell the difference between a concave polygon and a convex polygon. We've talked about congruent segments before. Remember, congruent segments are the same length. They measure the same distance. What are congruent polygons? We could say that they measure the same, but they're going to need to also have the same shape. Remember, we have different shapes of polygons. Line segments, we only had a line, so it was easy. They were all the same shape, and we just had to measure the same size. But polygons are congruent if and only if they are exactly the same size and shape. When we say if and only if, that really means that we can read this both directions. So two polygons are congruent polygons if and only if they are exactly the same size and shape. If I was to read it the other way, I would say if two polygons are exactly the same size and shape, then they are congruent polygons. So that if and only if means I can kind of read it forwards or backwards. So that statement can work both directions. Let's look at these congruent polygons. What do you notice about these markings that they have? Remember, we talked about how we can mark congruent segments with these little dashes. So if I look at segment CA, which segment would line up to it on this polygon? Hopefully you're saying SI, because SI and CA both have this one little mark here. So that means those are the congruent segments that would match up. What angle would match up with angle C? That's right, angle S right here. It has one marking on that angle. So then we can also see angle P has 4 markings and angle E has 4 markings. So E would match up with P. So if we just tilt this one a little bit clockwise, we could line it right up with this. And if we look at it, CAMP, we're going from the 1 marking on the angle to the 2 marking to the 3 to the 4. That's going to line up with the 1 marking and the 2 marking and the 3 and the 4. So SITE. Notice that when we're marking and naming the polygon congruent to the polygon, we line up the angles that match. We line them up in the order that we would go around and name it in the exact way that we would put this one on top of it to line them up. So that's important when you're listing congruent polygons, that you put the name in the right order and start with the right one that would match up. So you can name the polygon any way you want, but when you list its congruent polygon, you can no longer just start anywhere you want. You have to match up the congruent C to the congruent S, the congruent A to the congruent I, etc. Let's talk about equilateral, equiangular, and regular polygons. So these are all octagons. They all have 8 sides. This one is equiangular, this one's equilateral, and this one's a regular octagon. What do you notice about the equilateral octagon? It has these markings on each side. It has 8 identical markings. That means that all 8 sides have the same length. So an equilateral polygon means that all sides have the same length. An equilateral quadrilateral could be a square, but it could also be a rhombus. So we could have a rhombus that had the same length sides, or we could have a square. What about this equiangular octagon? Where are the markings? Only on the angles, and you can see that it got stretched out. So this side is not the same length as this side. So it's not equilateral, even though it's equiangular. So equiangular would mean that all the angles have the same measure. In this rhombus, the angles are not the same measure, but the square is. The square has 90-degree corners on all corners. So a square ends up looking like the same markings as this regular octagon. What do you think a regular polygon is? A regular polygon is both equilateral and equiangular. That means that all sides are the same length and all angles have the same measure. So a square would be a regular polygon. So would this octagon. On your notes, draw yourself a regular polygon. That's it for the end of this lesson. I'll see you next time.